In chemistry, there are times where you are required to name compounds. You'll be given a formula, the chemical formula of the compound, and you're required to give the name of the compound. In this video, I'm going to explain to you how you name chemical compounds if you're given the formula or the chemical formula of that compound. I have here a few examples. This is NaCl, then CaCl2, CO2, H2O, NH3, NaCO3, and H2SO4. Some of them are quite familiar, you already know the names, but I want to give you the systematic way of naming these compounds. I want you to learn that so that when you're given any compound, you can be able to name it. Now, this that I have here, this is sodium chloride. The next one is calcium chloride, and this is carbon dioxide, and this is water. This is sulfuric acid, and we have sodium carbonate and ammonia. Some of the names are quite common, so common that no one uses the chemical names per se. We just use these ones that we call the common names. No one says water is dihydrogen oxide. We just say it's water. Or ammonia is just ammonia because it's a common chemical. The same applies to sulfuric acid here. We just call it sulfuric acid. So I'm going to explain how you name these compounds. Something that you might have noticed is that on CO2, I say carbon dioxide. But on CaCl2, I don't say calcium dichloride. It is just a calcium chloride. Carbon dioxide, but this one is just calcium chloride. We don't say dichloride. There's a reason for that. Those are the rules that I'm going to give you. So let's start. The first thing, and actually the most important step when you are naming a chemical compound, is to know whether it is an ionic compound or it is a covalent compound. You need to know that because the rules are different. So know, is it ionic or covalent? Is it ionic or covalent? This is the first thing that you need to know. And then after that, second, you have to know the constituent atoms or ions. You need to know the names of the constituent atoms or ions. If it is an ionic compound, obviously it is made up of ions, and you need to know the names of those ions. And if it is a covalent compound, it is obviously atoms bonded together, covalently bonded. You need to know the names of those atoms one by one. This is a very important step. So you're going to see when I'm applying this. And lastly, third, apply the applicable rules. If we're given a chemical compound, the chemical formula is there. We have to ask ourselves, is it ionic or is it covalent? Then we know the names of the constituent atoms and the ions. Then we apply the applicable rules. I'm going to start with the first step on ionic or covalent. How do you know that it is ionic or covalent? Let me write this. Is it ionic or covalent? is it ionic or covalent? Please note that the rule that I'm saying here, I'm not into they're what we call organic compounds. The nomenclature, the system of naming organic compounds is quite different from these ones. So most of the compounds that I'm going to deal with here are actually inorganic compounds, although the rules also apply to organic compounds, but I'm mainly focusing on inorganic compounds because the naming of organic compounds is quite different from what we're doing here. So please take note of that. Is it ionic or covalent? It is easier for you to know that it is an ionic compound. If it is ionic, you should see a metal, a metallic element, and non-metallic elements. So this is how you see that it is ionic or covalent. You should see a metallic element and a non-metallic element together. Very, very important. E.g., if I'm just going to put two formulas here, and then I'll show you that this one is ionic and the other is covalent. And how do you see that? Let me have calcium chloride and let me have carbon dioxide. If you look on at calcium chloride, Ca is metallic. This is a metal. This one is chlorine, is a non-metal. It is therefore, we can conclude that calcium chloride is an ionic compound. So some of them you know it from experience, but this is a very simple way of deducing if it is ionic or covalent. Ionic compounds are formed when metals react with non-metals, forming ions that end up bonding together via a ionic bonding or electrovalent bonding, as it is called. Then you come to carbon dioxide. Carbon is a non-metal, and oxygen is a non-metal too. Once you have two non-metals bonded together, we call that a covalent compound. So this is a covalent compound. It is covalent. No question about that. Okay. So with experience, you end up knowing that, oh, this one is ionic or this one is covalent. It is a very important step in the naming of chemical compounds. You have to know if it is ionic or covalent because the rules are different. I think I'm clear on that one. Then we have what we call the ions themselves. So ions. How we name the ions. Naming the ions. Naming ions. So if it is an ionic compound, obviously it is made up of ions, and we have to name them. Let me use sodium chloride as an example. If you have sodium chloride, the ions here is Na+, and Cl-. The positive one is obviously the metallic ion. The ion from the metal is always positive because during this bonding, metals lose their valence electrons to form positive ions, and the non-metals gain these electrons. Then they end up forming negative ions, what we call anions and cations. So the positive ones are called cations, the negative ones are called anions. All right, how do we name our anion here? chlorine. The element, the original element was chlorine. But when we name these negative ions, we end with IDE. We now end them with IDE. So if it was chlorine, it is now called chloride. So when naming ionic compounds, the negative, or the N ions, the negative ions, the non-metallic one, it ends with IDE. IDE. It was chlorine, it's now IDE. However, the metal, the metallic one, remains sodium. So this is sodium, it is still sodium. So we name it as usual. It is still sodium. It doesn't change. All right, let me have another example. Let's say we have potassium oxide, which is K2O. We call this potassium oxide. K is for potassium, so K is potassium. This will be K plus, and the O is the oxygen. It will be O2 minus. Please see how I write here. I say 2 minus, not minus 2. We use 2 minus. This is the oxygen. Potassium is named as it is, so this is potassium. It remains potassium. So the metallic element retains the name, the metal name. If it was potassium, it remains potassium. It doesn't matter that it is now an ion, it remains potassium. But the oxygen, it is no longer oxygen. It now ends with IDE. It's now called oxide. So that the name here is potassium oxide. And here the name is sodium chloride. This is how we name these compounds. Then someone is going to ask and say, hey, how do we know metals and non-metals? How do we know metals and non-metals? It is also a very important part here, so that you can identify if it is ionic or covalent. You have to know that this one is a metal, this one is a non-metal. How do you know that? You go to your periodic table. So you go to your periodic table of elements. Periodic table of elements. Most of the elements on the periodic table of elements are metals. We just have a few non-metals, by the way. If I just let me draw a sketch of the periodic table, how the periodic table usually looks like. So it has this block here with two columns, which are essentially two groups. And then we have what we call transition metals here in the middle. So these are transition metals. Transition metals. And then we have other groups here. We have group 3 here. Then we have group 4, group 5, 6, 7, and okay, let me add another one here. And group 8. From group 1 to until group 3, all these are metals. So everything this side is actually a metal. We have metals here. So metals are generally on the left-hand side of the periodic table. Group 1, group 2, group 3, we have metals. And these transition metals are metals also. So we just have a few elements. And if you come to the metals, to the non-metals, yeah, it is not entirely the whole group. What you're going to see is, if you move down this group 4, they transition from being non-metals to metals, so that you end up having something like a step here where we go like this. See? So that the metals, the non-metals are just this part here. And they're not many, they're just a few elements. So we have metals this side. To the right we have to the left we have metals, and to the right hand side, extreme right, we have non-metals. All of group 8 elements they are nonmetals. The noble gases, they are nonmetals. Group 7, they are nonmetals too. In group 6, we have a lot of nonmetals. Group 5, we have nonmetals, but if you go at the bottom of the group, you may find some metals there. And the same applies to group 4. Carbon is a nonmetal, but as you go down the group, you find metals down the group. So in short, if you want to know whether it is a metal or a nonmetal, you rely on your periodic table of elements. If you know the periodic table of elements, you can easily know where are the metals and where are the nonmetals. I'm going to do another video explaining the periodic table of elements. It is a very important aspect of chemistry. If you understand the periodic table of elements, you essentially understand your chemistry. Now, I've explained that part of identifying metals and nonmetals. If we see just nonmetals bonded together, we know it is a covalent compound. If we see a nonmetal and a metal bonded together, we know that it is an ionic compound. Very, very important. Now let me go to the rules that apply to ionic compounds. Rules for naming ionic compounds. You need to write these rules for naming ionic compounds. You need to write these rules so that you can use them. Okay. 1, name the metal as usual. Name the metallic ion. Because these are ions, by the way. So name the metallic or positive ion as usual. When I say as usual here, I'm saying if it is sodium, you call it sodium. If it is calcium, you call it calcium. So, as usual. Calcium is calcium, so Ca2 plus. It is simply called calcium. This is the calcium ion. It doesn't matter that it's now an ion. It is still calcium. Then 2, name the non-metallic, metallic or negative ion, so that it ends with IDE. All right, a good example was if it is chlorine, it becomes chloride. If it is oxygen, it becomes oxide. If it is nitrogen, it becomes nitride. If it is sulfur, it becomes sulfide. They now end with IDE. Then the third rule, number 3, do not indicate the number of each. Do not indicate. This is a very important one. Indicate the number of each ion. Or let me just say atom. Fine, but you don't have to indicate the number of the ions of in that formula. You don't have to indicate. What I'm saying is, whereas we say dioxide, we don't say calcium dichloride. We don't say calcium dichloride. Even though there are 2 chloride ions there, we don't indicate. The di is indicating the number of each. Let me show this by examples, different examples. So I'm going to write what I will call ionic compounds. I'm going to start with calcium, Cl2. We call this calcium chloride. Calcium is the metallic element or the metallic part that gives us the calcium. This part here, we just name it like that. But the chlorine part, although we have 2 chloride ions, we don't indicate the number. We just say it's a chloride. It now ends with IDE. Let me give another example. Let's have Na2O. Na is sodium, O is oxygen, but it becomes oxide. Even though we have two sodium ions here, we're not saying a disodium. No, we just say sodium because it is an ionic compound. Let me have another example. Lithium, Li, H, LiH. This is lithium hydride. Lithium hydride. The same applies to NaH. It is sodium hydride. Okay, I know that this sodium is the metal here. We name it as it is. Hydrogen becomes hydride. You just need to get this pattern: hydrogen hydride, oxygen oxide, nitrogen nitride, chlorine chloride, bromine bromide, iodine iodide. What else? Sulfur acid sulfide. Okay. Once you understand this pattern, you can name any ionic compound without a problem. But we have other ionic compounds that I want to deal with, so ionic compounds with compound ions, what we call compound ions. Right. If I write Na2SO4, we call this a sodium sulfate. But if I split it up into the constituent ions here, I have this part here is Na plus. The positive sodium ions, we have two of them, and the other part, the S and the O, they move together. We call this SO4 2 minus. We call this the sulfate ion. This is the sulfate ion. Na2SO4 is still an ionic compound because it is made up of ions, sodium positive and the sulfate, which is negative. They come together because of electrostatic attraction. We know it from our physics that positive charges attract negative charges. That's how they come together. In fact, that is the ionic bond, where species with different charges come together through electrostatic attraction. That is what we call the ionic bond. Now the question is, how do we know all these compound ions? Because there are actually many. You have to memorize them, because most of the time you're not given these. You have to memorize them. So I'm going to list some of the common ones and their names, and you must know this by heart. You can, if you can Google it, or if you go to your textbook, you can find these named. One of them is NO3 minus. We call this the nitrate ion. Nitrate. So much so that if you see NO3, you can name this a sodium nitrate. So this is sodium nitrate. But today I'm not explaining, or in this video, I'm not explaining how you write these formulas. So someone is going to ask and say, how do you know that sodium nitrate is NaNO3? There is a way of knowing that. I'm going to explain in another video how to write chemical formulas. I'm going to explain that. But for now, I'm just interested in naming, given the formula. So we call this sodium nitrate. And we have another compound ion, by the way. It's compound ion CO3, 2 minus. We call this the carbonate ion. Carbonate ion. So much so that if I have BaCO3, we call this the barium carbonate. This is barium carbonate. So this is barium carbonate. We know the element barium. It's there on the periodic table, and this part here is the compound ion, which is called the carbonate ion. We have many. Let me just write some of them. SO4 2 minus. I said this is the sulfate ion. This is the sulfate. We have sulfate. We can also have bicarbonate. If I put H, CO3 minus, we call it the bicarbonate ion, bicarbonate. So much that if I write NaHCO3, we call this sodium bicarbonate, which is the bicarbonate of soda that most people use, baking powder, by the way, or baking soda, not baking powder, baking soda. This is sodium bicarbonate. So we get sodium bicarbonate, or what people call the bicarbonate of soda. In short, I can only name this sodium bicarbonate if I know the compound ion, this compound ion here, that it is called the bicarbonate ion. So you need to find a list of all these compound ions and their names and memorize them. You should know them, but with experience, if you're experienced in doing chemistry, you end up just knowing them, that oh, this is the carbonate, oh, this is the sulfate, this is the bicarbonate, this is the nitrate, there's also the nitrite, there's also sulfite. They are different. There's the chlorate, chlorides. There are so many. There's what we call compound ions. Otherwise, this is how you name ionic compounds. The positive part, you call it whatever it is. If it is sodium, you call it sodium. If it is barium, you call it barium. If it is potassium, you call it potassium. If it is calcium, it is calcium. But if you go to the negative part, which is essentially the non-metallic part, you change. If it was chlorine, it becomes chloride. If it was sulfur, it becomes sulfide. It starts ending with an IDE. But if you are having compound ions like the nitrate, the carbonate, the sulfate, you just have to know these compound ions. So much that let me just give a few names here. Na2SO4. I say this is sodium sulfate. We can have calcium. This is calcium carbonate. I can have a K2CO3. This is potassium carbonate. I can have CaNO3 2. This is calcium nitrate. I'm not explaining here why the formula is like this. I'm going to have another video where I explain how to write the formulas, but this is the formula for calcium nitrate. So these are ionic compounds, and this is how you name ionic compounds. If I have Na2O, it is simply sodium oxide. You don't have to indicate the number of atoms there or the number of ions in the formula. No, you just say calcium nitrate. That the nitrate ions are 2 doesn't matter. You just call it sodium sulfate. That you have 2 sodium ions there, it doesn't matter. You just call it sodium sulfate. The same applies to potassium carbonate. That is, there are 2 potassium ions, doesn't matter. You just say potassium carbonate. That's it. And this is how you name ionic compounds. Now I'm going to move to the naming of covalent compounds. Naming covalent compounds. compounds. The naming of covalent compounds is quite straightforward. The formula itself tells you the name. All you need to do is to know the names of the constituent atoms per se, so much that if I write CO2, this is carbon dioxide. That's carbon dioxide. Now I'm going to explain now the rules. Why we call this carbon dioxide, and how did we end up saying this is just carbon, and yet the other part we say we ended with IDE. Why didn't we end the first part with IDE? I'm going to show that. So let me write the rules for naming covalent compounds. Rules for naming covalent compounds. Okay, you are given the formula, and this is what you do. The first element, so rule number 1, name first element as usual. First element in the formula as usual. So if the formula is CO2, the carbon is the first element, you just name it carbon. If you have SO3, the first element here is sulfur, we just call it sulfur. All right. The next elements, okay, next element, or let me use the word following elements. The following elements must end with IDE. End with IDE. Remember, covalent compounds are made up of all of the elements in there are non-metallic. We have a few exceptions. I'm going to give a few exceptions where they are metals and non-metals bonded together, but it is a covalent compound. We have a few exceptions, and I'm going to mention those ones. And I think about 3. Then, so the following elements, the first one is named as usual, but the following elements should end with IDE. Then, rule number 3, indicate the number of each. Indicate the number of each atom. Sulfur is here. There's 1 sulfur. There are 3 oxygens. So we indicate the number of each atoms using mono, di, tri, tetra, etc. Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nano for 9, and deca for 10. So you have to indicate, if it is a covalent compound, you have to indicate the number of each atoms. That's why we say carbon dioxide, carbon and 2 oxygens. Sulfur dioxide. If it's SO2, we call it sulfur dioxide. SO3 is sulfur trioxide. We have to indicate that there are actually 3 oxygens. So I'm going to give another example. I'm just going to give an example of how to name something. This is N2O4. Let me do it systematically. N is nitrogen, so we're going to say nitrogen. I'm identifying the elements or the atoms in the formula. So N is nitrogen, O is oxygen. It is oxygen. I know that. And I have 4 oxygens here. And here I have 2 nitrogen. We said 4 is tetra. Let me list this. Mono is 1. Di is 2. tri, 3 tetra is 4, penta is 5. We should know this. So I have 2 nitrogens here and I have 4 oxygens. When I name this compound, I have to indicate that I have 2 nitrogens. And we know that the first element is named as it is. So this is dinitrogen. Dinitrogen. This is the name. Dinitrogen. The oxygen has to now end with IDE. So instead of oxygen, it should be oxide. But there are 4. We use the word the tetra. So it's now tetra. I'm going to show you something here. Okay. Please pay attention here. Because the non-metallic part, or this name here, oxide, starts with an O, we skip the A here. Because it starts with an O, we skip the A, such that we don't call it a tetra oxide. We call it tetroxide. So it's dinitrogen tetroxide. Okay, let me write this in green, it's fine. Tetroxide, not tetra oxide. So it's pentoxide, not pentaoxide. Pentoxide. If the name here is the prefix is having an A at the end, and the element after it is having an O or something, so we skip the A. Then we use the letter on that. So this is tetroxide instead of tetraoxide. If it is 5 oxygen, we're going to call it pentoxide instead of pentaoxide. We call it pentoxide. Very, very important. So this is dinitrogen tetroxide. Let me have another example. Let's have another example. Let's say we have, as I already named sulfur. This is sulfur trioxide. We can have something like S2, Cl2. Okay. This is a compound that exists. So this is disulfur dichloride. Disulfur. Sulfur is the first element, so we're going to name it as sulfur. We don't put the IDE at the end, so it's simply disulfur dichloride. So it's disulfur dichloride. That's it. This is how you name covalent compound. Any covalent compound, if you give it to me, I can name it. As long as you give me the formula and I know the rules, I can name them. If you give me any ionic compound, as long as I know the elements, which you can know them because you should know your periodic table of elements, and some of them are quite common. Now I'm just going to go to the exceptions. Exceptions for these rules, where these rules don't really apply. Exceptions. I have 2 exceptions here. We have Al3. No, not Al3. It is AlCl3. This is aluminium chloride. Although we name it as aluminium chloride, this is not ionic. This is actually covalent. It is covalent. Yet aluminium is a metal and chlorine is a non-metal. This is covalent. So aluminium forms covalent compounds with chlorine and even with fluorine. We also have BF3 and even BCl3. Boron, we call this boron trifluoride. It's quite interesting that aluminium, we just say aluminium chloride. But BF3, we say it's a boron trifluoride. We're naming it. This is covalent. It is covalent even though boron is a metal and fluorine is a non-metal. This is not an ionic compound, it's actually a covalent compound. And beryllium. So beryllium, let's say beryllium, we call this beryllium chloride, but it is also covalent. So please note that aluminium, boron, and beryllium are quite exceptions here because they form covalent compounds. Even though we expect them to be forming ionic compounds, they form covalent compounds, and the naming of those compounds is not as straightforward as these rules that we gave. That is the exception. Then we have another exception, which is the common compounds. Yes, these common compounds, they have names that they got from history. If we say H2O, if I write H2O here, no one would want to say dihydrogen oxide, which is strictly the chemical name, dihydrogen oxide. We just say it's water. It's a common compound. The same applies to NH3. We won't say this is nitrogen trihydride. We just say it's ammonia. We can say the same about H2SO4. See? This is sulfuric acid. We just call this sulfuric acid. It is a common compound. That is sulfuric acid. Then we have another one, it's HNO3. This is nitric acid. Nitric acid. These are common compounds and they have common names. We know them. So once we write NH3, we know it's ammonia. We call it ammonia. If I write H2O, we know it's water. We call it water. If I write HNO3, we say it is nitric acid because it is nitric acid and it's quite a common compound. So know the difference there. I think I have covered all the aspects that I wanted to explain. I wanted to explain how you name compounds. And I said the first thing is to know if it is ionic or covalent. Then you apply the rules for naming ionic compounds. And when you're naming ionic compounds, the first rule is you name the metal part or the positive part of that ion, of that ionic compound, as usual. If it is sodium, you just call it sodium. If it is calcium, you call it calcium. And the second rule says when it comes to the non-metallic part, if it is chlorine, it becomes chloride. In other words, it should end with IDE. However, there are some negative ions that what we call compound ions that are negative, like carbonate, sulfate, nitrate, bicarbonate, bisulfate, etc. You should know them. You should know them, or you should memorize them, so that when you're given a name or a formula like Na2SO4, you should be able to name this a sodium sulfate because you know that this compound ion here is called the sulfate ion. And I said when you're naming ionic compounds, you do not have to indicate the number of ions or atoms in the formula. You don't have to indicate that. But when it comes to covalent compounds, you can easily identify them because they are made up of non-metallic elements only. When you're naming them, the first element in the formula, you name it as it is. If it is nitrogen, you call it nitrogen. If it is sulfur, you call it sulfur. But the following elements should end with IDE. And the third rule, and most important rule, is you should indicate the number of each atom in the formula. If you have 2 oxygens, you're going to say dioxide. If you have 2 chlorines, you're going to say 2 dichloride. If it's 3, it's tri, 4 tetra, 5 penta, 6 hexa, going on like that. Okay, thank you for watching the video. If you have any questions, just put your questions in the comment section below. I will respond.